Humans have always looked up and wondered if anyone is looking back. In 1977, NASA decided to stop simply listening for a signal and to actively send a message out into the dark. The opportunity came from a rare celestial clockwork. Jupiter, Saturn, Uranus, and Neptune had drifted into a unique geometric arrangement on one side of the Sun, an alignment that occurs only once every 175 years. This formation allowed a spacecraft to use a gravity assist. By flying close to a massive planet, a probe catches a ride on its orbital path, steals a tiny fraction of its momentum, and whips around it, accelerating outward at massive speeds, while using almost no fuel. NASA launched Voyager 1 and Voyager 2 to exploit this window. Using successive gravitational boosts from the gas giants, they became the fastest man-made objects of their time. Because they were moving fast enough to break free from the Sun's gravitational pull, these probes were destined to leave our planetary backyard and become humanity's first permanent interstellar time capsules. When Voyager first left Earth, it functioned as a highly sensitive observer. The chassis was packed with 10 scientific instruments, including spectrometers, magnetometers, and 2 cameras designed to act as our remote eyes. As the twin probes sped through the outer solar system, they captured the first evidence of active volcanoes erupting on Jupiter's moon Io, and revealed that Jupiter also possessed a hidden set of planetary rings. By 1990, Voyager 1 was 6 billion kilometers away, nearing the edge of the known system. Before leaving the planets behind, scientists commanded the spacecraft to turn its cameras backward for one final family portrait. The resulting pale blue dot photograph showed Earth as a single, fragile pixel caught in a beam of scattered sunlight, emphasizing our isolation in the vastness of space. Immediately after taking that picture, NASA switched off Voyager's cameras. There was nothing left to photograph in the deep void ahead, and the shutdown saved crucial electrical power and computer memory. With the cameras powered down, the probe continued its journey as a silent, blind messenger hurtling into the dark. Ahead lay the heliopause. This is the invisible outer boundary of our solar system, where the protective bubble of solar wind finally gives way to the harsh radiation of interstellar space. For 22 years after its cameras went dark, Voyager 1 coasted toward this invisible border. Without cameras to show us the environment changing outside the ship, NASA had to find another way to prove when Voyager actually left the solar system. Data from the probe's plasma wave instruments was beamed back to deep space receivers on Earth. These sensors picked up faint vibrations from the surrounding void that the human eye could not see. This graph shows the result. Inside the solar bubble, the line remains low and flat, but in 2012, there is an abrupt vertical spike. That surge in electron density was caused by a barrage of interstellar wind hitting the spacecraft, a condition that cannot exist inside the Sun's protective bubble. This data provided the evidence. A man-made object had finally pierced the edge of the solar system and entered the space between the stars. Beyond its scientific instruments, the spacecraft carries a 12-inch gold-plated copper phonograph known as the Golden Record. The engineers who built it worked within a severe constraint. Voyager's entire onboard computer system had a storage capacity of only 69 kilobytes, a tiny fraction of the memory required for a single digital photo. To bypass this limit, NASA took 115 photographs depicting Earth, converted the video signals into audio waveforms, and etched those sound waves directly into the physical grooves of the metal record. The cover of the record acts as an instruction manual, using complex geometric etchings, calibration circles, and binary code to explain how to spin the disk and reconstruct the image data. These diagrams are so mathematically dense that even the majority of humans would fail to decipher them. Decoding the message requires a level of scientific logic that makes our attempt at communication a massive gamble. We sent this disk into the dark on the hope that whatever intelligence intercepts it shares our specific understanding of physics and mathematics. Voyager 1 is currently 24.7 billion kilometers from Earth, coasting through deep space at over 60,000 kilometers per hour. But the spacecraft is running out of time. The radioisotope generators powering its remaining instruments rely on the heat from decaying plutonium, and that fuel source is nearly exhausted. By roughly 2025, Voyager will lose the last of its electrical power. When that happens, the data will stop, and our communication with the probe will be severed forever. Once the systems freeze, only the physical hardware will remain. Bolted to its side will be the Golden Record, a time capsule that omits war and conflict to present a portrait of human art, nature, and curiosity. Long after the probe falls silent, and potentially long after humanity itself has faded, this dormant machine will continue its glide through the cosmos, ensuring that the best of who we were outlives us.